I am a professional design engineer. I have over 15 years' experience in the space industry. I've designed hardware that's gone to the moon, and I've worked on some pretty exciting advanced rocket propulsion technology. More than anything else, creative design is what I was put on this planet to do. This, though, is a story about the magic that you can create when you combine passions. In this case, when my love of design met my love of dancing, and made something priceless. Whenever I'm asked to give advice to young people, particularly young engineers, I always say, go and learn something that you're not good at. For those of us who are by nature bookish introverts, the obvious antidote is to go and do something physical and social. Not only does this teach us a little bit of humility, but it's also a great way to get to know the learning process. Most people would say, I can't dance, I've got 2 left feet, but the reason for that is that they never learned. And it takes a certain amount of confidence to be a beginner again, especially as we get older. There's another good reason to learn something that you're not good at, and that's that you'll get to meet people that you otherwise wouldn't have met. It worked well for me. Dancing is how I met my wife. Anyway, a few months back, a friend of mine who I know through dancing approached me and asked me whether I could 3D print a diamond. My mind immediately went to explaining that we can't yet 3D print a lattice of carbon atoms, and if I could do that, I'd be rich. But before I could make a fool of myself, she elaborated. She wanted a prop for a dance routine that she and her acro dance group were putting together. It was themed around a bank heist, and they needed something to steal. So basically a plastic cartoon diamond, pointed at one end and flat on the other, with lots of nice facets. No problem. Probably 10 minutes to design and 24 hours to print. I was pleased to be able to help. I made the diamond for them, and we talked about how to paint it. Basically acrylic paints, and painting with highlighting on the edges, stuff that I'd learned back in the day when I used to paint Warhammer miniatures. Then, as an aside, my friend mentioned that they were planning to mount the diamond on a plinth, and wouldn't it be cool if it was lit up and rotated or something? I'm fairly certain that the conversation continued after that point, but my mind was already running at 100 miles an hour. Yes, that was totally doable, and probably with stuff I already had lying around. I told my friend to leave it with me and disappeared into my office for 2 days. These days, my designs tend to start out in Fusion 360. I've used tools like Pro Engineer, Solid Edge and SolidWorks, and Fusion 360 is just as capable. I find the trick to a good design is the minimum number of parts. Keep things simple. Of course, that's where a designer's skill comes in. In the past, I might have had to do a more complicated first try, before starting over with a better design. I based this design around a brushless gimbal motor, mounted to a part that I call the bridge. All of the plastic parts that I used were 3D printed, and I designed this one so that I could print it from the side, so that I wouldn't need to use any support material. I could attach the motor securely to this using M2 screws. Next, onto the top of the motor I added a part I called the motor hat. This had a 3D printed screw thread on the outside, and I designed it this way because I didn't know what the diamond mount would actually look like at this point. The idea was I could later design any mount I wanted and simply screw it into place. 3D printed screw threads actually work surprisingly well. Next, I had to come up with a way of mounting a magnet in line with the motor. I designed a tiny 3D printed magnet mount and attached that to the base of the motor, using a long M2 bolt. This settled nicely onto the bottom of the motor and would freely rotate with it. I then attached a 5mm cube neodymium magnet using superglue. Brushless motors are just that, brushless. They don't have a commutator, so in order to work they need some kind of feedback. To do this I installed an AS5600 magnetic encoder onto the bottom of the bridge. That's what the magnet's for. With the encoder in place, everything rotated nice and freely, so it was time to hook up the electronics. For the electronics I used a Martinez-designed gimbal motor control board that I got off eBay. I liked this because it had almost everything I needed on one board. It's Arduino compatible, and to write the code I was able to get the libraries I needed off simplefoc.com. For this first test I was simply setting the rotational position using a potentiometer. It worked well, so it was time to mount it up on the box base that I designed. and try it with my first attempt at a diamond mount. Now the reason I configured the box this way is it gives good access to the working parts. The box lid can be mounted into the plinth, and then it's easy to install the mechanism from underneath. The only awkward bit is installing the diamond mount, which has to be screwed down onto the motor hat. If I was designing it again, I probably wouldn't do it this way. I soon received a message from my friend saying that she'd finished painting the diamond. Practice for the routine was also coming on pretty well, which was good because the performance date was looming. We met up for a first quick test of the diamond in the mount. Maybe a bit slower. Then all I had to do was think about the lighting. The gimbal board has two 3-channel half bridges. I was using one for the motor, but my plan was to use another to control an LED strip. I used rectifier diodes to effectively turn them into transistors, though in hindsight probably not necessary. I also added a 5-volt voltage regulator and a nice juicy capacitor. We also needed a control button, so I wired this up with a pull-down resistor. I had reprinted the box top in white, and this was now permanently mounted in the plinth. Once the mechanism was ready, all I had to do was install it from underneath. From there it was all wiring and electrical tape. I put together a little box with a potentiometer to control the rotation speed, and the control button. The power came from a little box with 4 AA batteries, which also had the on-off switch. All that left was to install the LEDs, and to admire our handiwork. Performance day. The team were going through their steps, and I had my last opportunity to check everything was working. We'd swapped out the plastic diamond mount for a perspex cylinder, which I thought looked great. We'd also added in an extra feature, which is what the control button was for. Time to give that one last check. And then, performance time.
Cops and robbers, enjoy!
I have to say that I was very pleased at the reaction that the spinning diamond got from the audience. Something that we'd talked about was ways to synchronise the LEDs to the music. Remote control from the audience, perhaps. I'd insisted that the simplest solution is often the best.
Activating alarm system.
Especially when you had someone on hand to press the button. This simple system works like clockwork, literally. I just wish the LEDs showed up better on camera. The nice thing is, events in the music always happen at exactly the same time interval. Perfect. This was a really rewarding project to work on. I've told you all about my little contribution, but really the most impressive thing is the routine that my friend Amy and her dance partner Adrian put together. If you want to see the whole routine, I've linked it here on the left. And if you live near Oxford and want to learn how to throw humans up in the air, then look them up. If, on the other hand, space, aircraft or design are your cup of tea, at least for today, then I've posted some of my other content on the right. And of course, if you enjoyed this video, don't forget to like, subscribe and leave me a comment. I'll see you on the dance floor.